friends, this video on Neet wave optics is brought to you by examfear.com. No more fear from exam. Question number 1. The interference pattern is obtained with two coherent light sources of intensity ratio n. In the interference pattern, the ratio I max minus I min divided by I max plus I min will be. Okay. So we have already learned about the concept of interference and what happens when two waves from coherent sources interfere. Now here in the question, let's first see what is given in the question. So the first thing that is given is the ratio of the intensities is n, that is I1 by I2 is equal to n. If we assume I1 and I2 are the intensities of the two waves coming from the two coherent light sources, right? Now we have already learned that when we have two waves of intensities I1 and I2, then the resultant wave will have intensity I, which is given by I1 plus I2 plus 2 root over I1 I2 into cos phi, where phi is the phase difference between the two waves. Now here we are looking for the maximum value of intensity and minimum value of intensity. So the value of intensity will be maximum when cos phi is equal to 1, because whenever cos phi is maximum, I will be maximum. When cos phi is minimum, I will be minimum. So the maximum possible value of cos phi is 1. So therefore, I max will be equal to I1 plus I2 plus 2 root over I1 I2, which can be written as root over I1 plus root over I2 whole square, because a plus b whole square is equal to a square plus b square plus 2ab, right? So this is what we get for I max. In a similar way, we can say that the value of I will be minimum when cos phi is equal to minus 1, because that is that's the minimum possible value for cos phi. Now when you put this value of cos phi, then I minimum is equal to I1 plus I2 minus 2 root over I1 I2. So this can be written as root over I1 minus root over I2 whole square. Now see friends, actually here you might feel that no, this is a very long method. So this is not actually long method. Why I am doing this is I am trying to tell you from where do we get this. Now most of the times what I understand it, for fast calculation, most of you will remember this formula for I max and I min. But in case you forget the formula in the examination hall, then what do you do? So for that purpose, it is always important that you understand from where do you get these. Okay. So now it is pretty simple. So you can say I max minus I min divided by I max plus I min. So this can be written as root over I1 plus root over I2 whole square minus root over I1 minus root over I2 whole square divided by root over I1 plus root over I2 whole square plus root over I1 minus root over I2 whole square. So after this, it is going to be simple mathematics, right? So a plus b whole square, you can expand it. A minus b whole square, you can expand it. So what you get is, now I am not willing to do the entire calculation. However, you can do it yourself. Like it will be like I1 plus I2 plus 2 root over I1 I2 minus I1 minus I2 plus 2 root over I1 I2 divided by, in a similar way, I1 plus I2 plus 2 root over I1 I2 plus I1 plus I2 minus 2 root over I1 I2. So this two terms will get cancelled. Here these four terms will get cancelled. So we will be left with 4 root over I1 I2 divided by 2 I1 plus I2. So if you further simplify this, what would you get? So on further simplification, now okay, in the question it is given that I1 by I2 is equal to n. So we have to give the answer in terms of n. So from this you can say that I1 is equal to n I2. Now in this expression, instead of I1, you just put n I2. So then the ratio becomes 2 into root over n I2 square divided by n plus 1 into I2. So this becomes equal to 2 root over n divided by n plus 1 into I2 divided by I2. So these two will cancel. So this would be the answer. So which is the correct option? It is option B. Question number 2. A linear aperture whose width is 0.02 centimeters is placed immediately in front of a lens of focal length 60 centimeters. The aperture is illuminated normally by a parallel beam of light of wavelength 5 into 10 to the power minus 5 centimeters. The distance of the first dark band of the diffraction pattern from the center of the screen is. Now, very simple, it is talking about diffraction. Let's quickly recollect the concept of Fraunhofer diffraction of light due to a single narrow slit, because here it is talking about a single aperture, a linear aperture or a single aperture. So it was somewhat like this. So you had a linear aperture and you had a screen here, and you also had a lens in between somewhere here. And let's say that the width of the slit is A, and let us also say that this is the lens whose focal length is given in this problem. So let's say that this distance would be the distance of the screen from the lens, right? And this is where we see the diffraction pattern. Like as we know, you have a central maxima followed by secondary maxima and minima on either sides. So this is how the diffraction pattern would be. Okay, so now we have to find out the distance of the first dark band of the diffraction pattern from the center of the screen. So basically we are talking about the first minima, right? That means we are trying to find out the secondary minima corresponding to n is equal to 1. So that's basically the question, right? So now, how do we calculate the position of secondary minima? So we have the expression yn is equal to n lambda capital D divided by A, or D, whatever, if you call this distance as D, then you can write it as D. So this is how we calculate the position of the secondary minima from the center of the screen. Perfect. So in this case, n will be equal to 1 because we have to find out the first dark band. So we put n is equal to 1. So then yn is equal to lambda capital D divided by small d. Now do we know the value of small d? So here in the question it says that the aperture has a width of 0.02 centimeter. That means the value of small d is 0.02 centimeter. Okay, what about capital D? That is the distance of the screen. How do we calculate that? So here we see that in the problem the focal length is given. Now in these cases, the focal length of the lens would be equal to the distance of the screen from the lens. Why is that so? That's because why do we have this lens here? The purpose of this lens is to focus the parallel beam of light onto the screen. So what does a lens do? Whenever a parallel beam of light passes through it, it converges them to a point, and that point is the focus. So basically this screen, wherever the screen is located, that is the focus, because that is where the rays of light are getting focused. So that means this is the focal length, and this is also the distance of the screen from the lens. So we can very well say that this can be written as lambda f divided by d. Perfect. So now let's put the value. So lambda is given as 5 into 10 to the power minus 5. What is the value of focal length? It is given as 60 centimeters. So 60 into 10 to the power minus 2 meters divided by d is 0.02 centimeters. So this will again be multiplied by 10 to the power minus 2 to convert it into meters. So now when you calculate this, you get 150 into 10 to the power minus 5 meters, which is equal to 0.15 centimeters. So the correct option is D. Now let's look at question number 3. The intensity at the maximum in the Young's double slit experiment is I0. Distance between two slits is d is equal to 5 lambda, where lambda is the wavelength of light used in the experiment. What will be the intensity in front of one of the slits on the screen placed at a distance capital D is equal to 10d. So let us draw a rough diagram to quickly remember the setup of the Young's double slit experiment. So here you actually have two slits. Let's call this as S1, this is S2. And here you have the screen. Perfect. So now it says that, so on the screen what do you get? You get alternate dark and bright bands like this. So if we assume that this is the bright band, then this is the dark band. Again, this is bright, so this is dark, this is bright, this is dark. Similarly, this is dark, and so on. So this is how you see the interference pattern on the screen. So now in the question, it says that this distance between the two slits, that is D, which is given as 5 lambda. Okay, and we will have to find out the intensity in front of one of the slits. So this is, let's assume this is one slit exactly in front of this slit, maybe this point P, and we have to find out the intensity at this point P. So how do we find that? So in order to find the intensity at any point P, we need to know a couple of things. So what are those things? We need to get some idea about the path difference. We need to find out the position of the point P. So let's see, how do we start? Okay, so now in this question, it is also given that the maximum intensity is given as I naught, because it says that the intensity is maximum and this maximum intensity's value is I naught. So we know that in general, how do we find out intensity of the interference pattern? Like if you want to find out randomly the intensity at any point on the interference pattern, how do you do that? So you find out using this expression, I is equal to I max cos square phi by 2. So we have already learned about it, right? That how do we find intensity? So it is I is equal to I max cos square phi by 2. So in this problem, I max is given as I naught. So you can write it as I naught cos square phi by 2. So that means basically to find out the intensity at any point, all you need to know is the phase difference phi. So basically for this point P, you will have to find out the corresponding phase difference. And how do you find phase difference? For phase difference, first of all, you need to find out the path difference, right? So let us first calculate the path difference corresponding to point P. So the path difference would be how much? So how do we find path difference? Small d divided by capital D into y. So small d is the distance between the two slits, capital D is the distance of the screen from the slits, and y is the distance of this point P from the center. So center is this point. So this distance is y. So here in this case, small d is given as 5 lambda. Right? And what about capital D? So it says that capital D is equal to 10D. So we can write it as 10D. Okay, instead of doing so much of complication, what we can simply do is, let's keep it as small d. Capital D is given as 10D into y. Right? So this D and D will get cancelled. So we are left with, so the path difference is y by 10. Now, can you tell me what would be the value of y? So y is basically the distance of point P from the center. So center means this point, the center between the two slits. So from this point till one of the slits. So basically the value of y will be half of the value of d. Right? So y can be written as d by 2. And d is 5 lambda. So 5 lambda divided by 20. So this is equal to lambda by 4. So the path difference is lambda by 4. Now how do we calculate phase difference? Now we know that for a path difference of lambda, which is like, one complete wavelength. So for a path difference lambda, the corresponding phase difference is equal to 2 pi. 2 pi is 360 degrees. So 360 degree. One complete angle corresponds to a path difference of lambda. So therefore, for a path difference of lambda by 4, phase difference would be equal to 2 pi by lambda into lambda by 4. So this is simple mathematics. So this is equal to pi by 2. So that means the phase difference corresponding to the point P would be equal to pi by 2, which is 90 degree. So now we know phase difference. Now we had already derived this expression for intensity. So we can also find out the intensity corresponding to point P, which will be equal to I naught cos square phi by 2, that is 90 degree by 2. So this would be I naught cos square 45 degree. Cos 45 is 1 by root 2. And so 1 by root 2 whole square. So this is equal to I naught by 2. So the correct option would be C.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.